Well, hi, good morning. Thank you for joining me in my shop. Today is October 3rd and day 2 on this radio. So not so surprising to me. I was able to make it work yesterday. Not so surprising because there was a note on it saying that it worked to some degree. So the next step here, I'm pretty sure, the next wise step is just to start changing a few capacitors under here. I like to take a bit of a programmed approach to that. Don't really want to just do them randomly. So the first one I like to go after is what's called the blocking capacitor or grid blocking capacitor for the output tube. The output tube is, I think it's this guy here. So we'd be looking for a capacitor, maybe it's this tube. No, this is a 6SQ7. This will be the output tube here. So that's the output tube. Well, I don't see a capacitor coming to it offhand. Oh, here's one down here, hidden away. This is probably it here. So we're going to take a look on the yeah, exactly. We're going to take a look on the schematic and just see a little more about this. Here we are. Okay, pretty simple radio. It's one of the things I like about these radios is they don't have a lot of parts. I mean, this is really pretty empty. The schematic looks empty. The radio looks pretty empty. So let's find. Here's the output tube. These tubes are upside down from normal, the normal way they're shown on a schematic. So the plate is at the bottom and the cathode's at the top. Grid is here. That's the capacitor right there that I need to find. C20.01. Now I've got there's a lot of good information with this radio. Let's take a look at some more of it. How about this? So this will show us where A1 is according to this. Now let's get oriented here. So I have the radio, this side is down on my bench and this is the high side of the radio. And power transformers here. And the capacitor I picked is sitting right over here. Let's take a look. Plate, grid. Here's the grid. There's C20. So they're not showing this so pictorially. It's sort of semi-pictorial because in my radio C20 is tucked under here. It's not run this way, but that's okay. C20. Wait a minute. This is going to the plate? Didn't I just follow from the grid? Oh, wrong tube. That's the problem. Oh, okay. Almost made a dumb mistake there. Grid. Yes. Okay. Okay. So this capacitor is going to get changed, but before I do it, we're going to test the radio out and find out what the voltage is on this side, where it's connected to the plate of this tube, and what the voltage is on this side. Now, something else we have to take a look at when we're looking back on the schematic is how is the bias arranged here. So here's the cathode. There's a capacitor there going to the plate. Between the plate and the cathode. This is tough to do here. Oh, here's the resistor, R8. R8 going to shield. Okay, not making sense to me. Okay, not a lot making sense to me looking at this diagram. So let's go to the schematic, and I think I'll be able to understand things better here. Zoom in a bit. So what all was I looking at? We want to look at the cathode here, and it's tricky how they've drawn it. Here's a cathode resistor right here, and this must be a capacitor that is sometimes there, sometimes not. 20 microfarads. I don't know why they have it dotted, so maybe it exists in some radios and not in others. This would be a bypass across this resistor. 390 is a very typical kind of resistor range, anywhere from 100 to 300, 400, 500, something like that. And there's another 0.01 coming right off it. We'll probably have to replace this one too, but the one we're really interested in is this one. Okay, so step 1, turn on the radio, get it operating. Step 2, measure the voltage here and the voltage here, and excuse me, the voltage on the cathode. Cathode should show a positive voltage of some amount. 6F6 output tube. And we'll just take these measurements. Then we're going to replace this and then repeat these measurements here to see the fantastic improvement, if that's really the case. So what am I talking about? If you're really new to this, then why is the concern here? There's a fairly high voltage over here, not full B+, but probably 60, 70, 80 volts sitting here. And this connection, this line here, has to be connected to the grid to pass the signal through. But this line has this high voltage on it, or voltage on it. We don't want that on the grid. So we put a blocking capacitor here to block the plate voltage from the preceding tube and block it from getting to the grid of the next tube. The grid of this tube should measure 0 or very, very close to 0 volts when measured to the chassis. The bias is really caused not by making the grid negative, but by making the cathode positive, which has the same effect in the end. So, okay, that's what we're going to do. Okay, before we turn on the radio, let's do a little practice here, because the capacitor is in a bit of a hidden spot. Okay. Now, reading the voltage on a grid circuit can be tricky if your meter's not good. Now, in today's world, everybody's meter's good. You know, these kinds of meters are good. But in the older days, and I'm just looking for one of these older meters here. I thought I had one right here. Here's one. This is more like a battery checker. That's not really a test instrument as such, but little meters like this are old meters, which I cannot put my hand on right now. They draw too much power from the circuit under test. In some cases there's power available, so it doesn't really disturb the circuit, but in other cases there's just not enough power there. When you hook up the meter, it'll cause a significant effect to the circuit you're testing. And this was the situation back in the 40s and 50s. In repair shops, guys didn't have vacuum tube voltmeters like this. So this particular voltmeter I'm using is high impedance, high input impedance of, I can't remember for sure, but I think it's 10 megohms, which should not disturb any circuit except for grid circuits. Grid circuits are very, very high impedance or high resistance, and so bleeding off a little bit of charge, even with this meter, can reduce the voltage reading and make it misleading. So let's practice first. I can't see the end of this capacitor here. There's some pretty clunky soldering going on in there. Oh my gosh. So I'd have to come in something like this to get that end, and then the other end, I believe it's right here. Yes, no doubt. So the end that's on the output tube is here. So when I test here, the reading should be 0 on the meter. And this end over here, which is really hard to see what they've done here. Let me get a flashlight. How about a flashlight that works? Okay. Well, it looks like what they've got here are I don't know what they got going here. Gigantic connection. It's got to be the spot though. Right there. Okay, I think I'm ready. So we want to turn on the set here. Volume down. Switch is on. Here we go. And we should do this with full line power. 103 volts. Let's go just a wee bit higher. A little higher yet. 107 volts. Should be up above 110, really. Okay, 110. Tune it in a little better. So the radio sounds very tinny. It's out of its cabinet, so the speaker won't produce bass very well at all. And I think it's part of why it sounds so tinny. Well, you gotta really advance the volume a long ways. Something not quite right there. Distortion too. Low volume, high distortion. Let's check this bias out now. So we'll look at the supply end first. I'm expecting 60 volts. So on this meter, with that setting, we're talking about straight up, something like that. And so this was the terminal. I got nothing at all. So what happened there? Let's check for the B plus voltage. 150, well, it could be well above that. Let's go up here. So I'm on a 500 volt scale. We expect the B plus to be again straight up on here. Yeah. So now why didn't I see some of that over here? Let me try and get right on that capacitor lead. There I am. See the voltage there? It's like nothing. So we have low voltage. So this is a different problem now. We have low voltage on the plate here. And next to nothing. On a 50 volt scale, that's like 4 volts. That'll never do. It's amazing the radio works at all. So is there a chance I'm on the wrong pin? Yes, there's always this chance. Let's go to the pin next to it. Nothing happening there. Possible I've got everything all wrong. It's always possible. Okay, so let's look over here, and this is the output tube again, and we'll look at the cathode, and the cathode here. I got this all messed up, do I? Yeah, this is the grid here. So it's not showing any positive voltage. I make my meter just a tiny positive voltage there, like that's a tiny, but there's not much on the other side of the capacitor. Let's try that again. I'm on the 500. Let's go on the 50 volt scale. So it should throw it right over. That's all it does. The meter should go right over. Okay, so we got a problem with the B plus reaching that tube. No problem with bad biasing on the output tube because the earlier tube has no B plus voltage to leak. Let's take a look at the schematic here. So what I'm finding here is almost no voltage here. How would you get no voltage? How does it get its voltage in the first place? Here's the plate. That's a skip. This is a connection. This is probably the B plus line here. Yeah, I should move that. Yeah, here it is, coming right out of the oh, this is a field coil speaker. I didn't even recognize that. Field coil speaker, small filter capacitors. What's that? Link. That's an odd thing, isn't it? Link. Okay, so anyway, the B plus comes up this way, comes and it's distributed on this line, comes through this very large resistor, and feeds B plus voltage to here. Now they haven't written what it should be, but typically, you know, if you've got a 250 volt B plus supply, probably only 75 of it is going to be applied to this plate, and that's the job of this big resistor. So chances are, the job of this big resistor is to drop the voltage. Chances are this guy has gone way high, or even, yeah, just gone high. I was going to say, or even opened, but if it was opened, we get 0 here. So we got to find R6, 470,000 ohms. So we'll look at this other diagram here. Oh, there it is right there. But again, this is not shown pictorially. What's this? Why this special looking wire? Did they explain it anywhere? There's no notes on here that are going to explain this. Also, where else do you find a heavy wire like this? Why just here? Why would that be? So often when I'm doing these videos and I raise questions that I don't have the answer to, you might have the answer. Go ahead and throw it in the comments if you think you know why they did this. We look on the radio, it may become apparent. So it's picking up from the screen grid, which this wire then is going up to the coil on the speaker, and probably coming back on this wire, and there we are right over to the filter capacitor. So there you are, there it is. Okay, so we're going to find R6. What size was it? What size was it? R6. It was a 390. They didn't put the wattage here. Wrong one. Over here. 470. Half a million. Okay, we'll find it. We will find it. So I think at this point I can turn the set off. And so these resistors are color coded using an old style of color coding. The way to remember it is body, end, dot. Those are the three colors: body, end, dot. So the body is the bulk of it. So this one would be yellow. You can see that in the camera. The end is purple. So that's 47, and then there's a dot. Could be a band, or could literally be a dot of color. We don't see it. It could also be yellow. If it's yellow, then you can't see the dot on the yellow body. Kind of crazy, right? I think that's why they got rid of this system in the end. It really wasn't working out. So if that's the case, then this would be yellow, purple, yellow, and that would be 470K right there. It's connected to the grid, and the other side, I'm pretty sure this is a grounded connection. So this is the 470. Let us stick an ohm meter on it. See what it says. I should say that this appears to be the 470. So instead of 470, it's 550. That's not nearly what I was expecting. 470, 550 in this situation is not much different. So this isn't explaining it. Explaining the low voltage. So what if this capacitor is badly shorted? then it's going to I'm confused. I've confused myself here, haven't I? Because here's another resistor here. Yeah, I've confused myself. I have to look at the schematic and get unconfused here. What happened to you, man? Oh, maybe this is it. There's a 470 here, a 470 here, and that's what's happening. So I'm finding the 470 here. This is the one I tested, which tested at, what was it, 530 or something. That won't matter. It's this one here I've got to find. I'm on the wrong side of the capacitor. So what's going on here? Okay, so I think I did see the other one, and it does look to have the same colors, and it's just as beat up. So let's go back and we'll test what I'm sure is this one. Bearing in mind that me claiming to be sure of something really doesn't mean anything. But let's go with it here. So I think it goes from this terminal to here. Well, we have 4,000 ohms already, and the 4 million. We got 4 mega ohms here. I have the feeling the resistor is open completely, but I think we would get an open reading. Okay, well, with that there, we are going to nip it on one end. I'm on my way to replacing it. Oop, let's get a clip lead here. What happens to me, maybe happens to everybody, is I'll be in the middle of working on something like this, and I'll have to leave, answer the phone or deal with a cat or whatever. When I come back, I can't remember what I was doing, where I was looking. So if there's a terminal I'm going to have to solder back a wire to, I do two things. One is I leave a tail of wire from the original part, which I can spot. And I also put a clip lead on because I'm just that dumb about this. Seems like if there's a way for me to find a bad way to do something, I tend to find it. Okay, we're going to nip this resistor out of here. And it's right in the conglomerate of solder here. There it is. Here it is. Now, the truth, let the truth be known. Because we can test this outside now. Really? I said I thought it was open circuit. I think it is. Well, that's 36 mega. That's 36 mega. Yeah, it's as good as open. So we're going to put a new resistor in, and we're going to get volume out of the radio, no distortion, and then we're going to find out if that capacitor is leaky or not. New resistor goes in. Okay, I think we're ready for another try here. I've got the new resistor in there. I don't know if you can see it. Yeah, I guess you can see it there. And we're ready on the voltmeter, either side of that resistor. Okay, let's power up the radio. Anybody see the dangerous thing I just did? So I took this, put it like that in my hand, and then went about doing stuff. You know, that's a bad habit, to slip a tool in the back of your hand while you do something else. Cause you see how close I came to stabbing the speaker, or who knows what. Like the worst thing is to do that with a soldering iron. That's bad. Don't do that. I'm telling myself. Okay, now power on. Dim bulbs. Okay, same reaction. Nothing different. Wouldn't expect something different. And we'll give it the full shot here. Ooh, what was that? That didn't sound good. That sounds better. Okay, look at the volume we've got now.
To move into the new building.
And I'm not going to turn it up high enough to see where this distortion is. It's way beyond the normal. So let's measure now on the plate side of the resistor. We're expecting maybe 100 volts there. This is the 150 volt scale, so maybe up in here. So 75 volts. Okay, and on the other side of the capacitor, which is now holding back 75 volts, is it? So you see the meter come up. So this is the grid that should be 0. So we're going to put this on the 50 volt scale and take a look. So 50 volt scale, 10 volts coming over. 15 volt scale, just to show you, 12 volts coming over. So this is destroying the bias on that tube. That's all we need to see. When the output tube is not biased properly, you can't necessarily hear anything in the speaker. Nothing seems any different from anything. But meanwhile, the tube's throughput of current, the quiescent current, or the constant current that goes through it, is way higher than it should be. And what this does is it burns off the cathode. The cathode only has so much life in it. Most of these cathodes are coated cathodes, and as they operate, they wear out. They ablate to some degree, just from the heat, I guess, and the atomic action that's going on with all these electrons flying around and stuff happening. It wears out. So a radio in this state will wear its output tube out very quickly. Then you run to the tube store, get another tube, stick it back in there, everything's great, but you're burning that tube out too. In the worst case, if this gets really bad, then the radio becomes distorted and inoperable, just from bad bias. So that's very good, but to really solve this, we have to go after the capacitor that's down there, which is really what we set out to do originally. So I'm going to nip it here, try to leave enough lead that I can test it. And we're going to nip it out over here into this gigantic blob of solder that has developed here. This is usually where I cut what I'm after and something else. Nothing else to, oh, I don't know if I got enough lead. Yeah, I could probably test this. Made in Canada. Okay, so we're going to put this on the tester. Let's see how this goes. Let me put this over here like this. Okay, so we're on the 50 volt setting. I would expect this capacitor to show a dramatic leak. That'd be my guess. A dramatic leak. The eye, which you can barely see, will close and not open. Oh, total baloney. Now that's testing the other extreme. It's popping right open. It's not closing at all. It should close a little bit. Now maybe I don't have a contact here. Maybe that's what's happened. Let's try again. Let me wiggle it here. Wow. I think this capacitor has no connection. Let's give it 250 volts. I don't know what's going on with this thing. I mean, the radio worked with it in there. It had to carry the audio through it. Let's so this thing's great at testing good components, but bad components, any tester can be fooled, I think, by a bad component like this. Let's see what it says. What does it say? So this may not be valid at all. It's just something to do for fun. It said it's a capacitor. Okay, so 28 nanofarads, that's a 0.02. Loss is 11%. A 0.02, but it's supposed to be a 0.01. Well, when these things read high, I attribute it to a leak in the capacitor itself, throwing the test off. There goes my phone. Oh, voicemail. I was going to show you what my phone said. It says likely spam on it. So we get phone calls that are probably spam phone calls, and our phone system will tell us it's likely a spam call. But by the time I got it in front of you, it had already gone to the message. So yeah, I'm not going to answer it. If it says spam, not answering. Okay, remember to turn off my tester. So we need a new 0.01 in here. Yeah, I don't know what to make of all that. But certainly the test of the positive voltage on the grid side is a very strong indication of a leaking capacitor there. Especially when we didn't see that voltage before putting in the resistor and getting the higher B+. So I will put a capacitor in there. We'll repeat the test. Okay, I've got the new capacitor in there. Maybe, yeah, you can see it there. And get ready for the test again. Volume down. Dim lights in. Dim lights show everything's good. Supply voltage is 110. Ready here. So on the high side,
and the former school gym is where they...
It's working. That's good. So over here, we're looking on the high side. We aren't. What are we doing? So that's a 150 volt scale. That's straight up 80 volts on my meter. Oh, can't see the meter. What happened here? Okay, repeat that. 80 volts on the plate of the triode that's feeding the output tube. On the other side, on the grid, nothing there. 1.5 volts all the way. So a little tiny positive voltage there, which is quite common. Maybe, I don't know what that would be. Still leaking through a perfectly brand new capacitor. Wow, I don't know. Maybe tiny charge coming through. Or it's more likely the tube is generating that through maybe a touch of gas in the tube or something of that sort. So there we are. That's all I'm going to do today. So now we can operate this radio more safely, in the sense that there's no risk to the output tube that I'm aware of at this point anyway. So let's give it a little run here.
Largest station in Canada and the #1 news brand. We're here to support.
Somehow the tuning seems sharper. I can't imagine why that would be. I'm picking all these stations up here. I don't get it. It's the dial backwards? Wow, it's just picking up stuff everywhere.
On now at Visions Electronics. For savings in every department store-wide. TVs, home audio, appliances, laptops,
Let's go.
computers, and more. Plus no payments and no interest until 2026. The super sale.
No payments, no interest till after you're dead. Can you think of anybody who sells you stuff that you get after you're dead? Can you think of any organization which is offering you something that you get after you're dead? You think about it for a bit. Because I got some land. Pay me now, and when you're dead, you can have the land. Okay. Enough sarcasm. Well, that's great. That's a good first step, and solved a hidden problem with the resistor that was bad. That's good. I like that. Okay. Well, tomorrow we'll just keep working, chugging through those capacitors. Thanks a lot for watching, and I'll see you. Bye.